Let's take a look at absolute value equations. Now, up until this point, we've dealt with linear equations and linear inequalities. Linear equations, our solution generally involves just a single value, where linear inequalities, the solution is a set of values called an interval. Well, with absolute value equations, we're actually going to have two values for our solution, and we'll see why that is in a second. So let's go ahead and take a look at the first example. We have x plus 5. The absolute value of x plus 5 equals 3. Now, with absolute value equations, there are two possibilities. The expression inside the absolute value bars is either negative or it's positive. And either way, we can actually still get the same answer. And why that is, let's go ahead and, not to insult your intelligence, but the absolute value of 3 is what? Well, we take the number inside the absolute value bars and make it positive. So we just get 3. Well, the absolute value of negative 3, if we apply the absolute value bars, will still give us a positive 3. So we see that the positive and the negative version of a single number can give us the same number. Well, we need to treat expressions the same way. X plus 5 can either be the negative version and give us 3, or x plus 5 can either be the positive version and give us 3 as well. So what we're going to do is we're going to write both equations separately and then solve them separately. And we're going to do it like this. So let's say we're going to have x plus 5 equals 3. Just drop the absolute value bars. And the other possibility is x plus 5, just the expression, not the absolute value expression. It can equal a negative 3. Okay, just imagine that we're replacing x plus 5 and 3. And we're replacing minus 3 with x plus 5. All right, so we're just doing a little substitution here. There's no magic going on. We're just considering two different possibilities. So let's go ahead and solve these. Let's subtract 5 from both sides. These two terms will cancel. So we have x is equal to minus 2. That's one possible solution. Let's go ahead and solve the other one. So subtract both sides by 5. Those two terms cancel. So we have x equals minus 3 and minus 5 is minus 8. And that's our other possible solution. Now, we can substitute either minus 2 or minus 8 into x in our original equation, and if the equation holds true, then we have a valid solution. These values would be valid for the solution for the equation. So let's go ahead and check this. Let's plug in minus 2 into our original equation. So we have the absolute value of minus 2 plus 5 is equal to 3. All right, let's go ahead and solve this. We have 5 minus 2, so we have the absolute value of 3, which we saw up here is indeed 3, so that checks out. All right, let's go ahead and check the other one. So let's plug in minus 8 into our original equation. So we have the absolute value of minus 8 plus 5 equals 3. We're just plugging in both values into our original equation and seeing if it holds true. If so, then we have a valid solution. Minus 8 and plus 5 is a minus 3 equals 3 is on the right hand side, and we saw up here that the absolute value of minus 3 is indeed 3, so that checks out. So these two solutions are indeed valid. All right, not a whole lot to these. We just need to notice that when we're dealing with absolute value equations, there's two possible values for one linear equation. It's kind of counterintuitive to think of it like that because we're used to seeing linear equations just having one value for the solution. So let's take a look at the next one. We have the absolute value of 2x minus 4 is equal to 8. Okay, so since the absolute value bars render a non-negative number when applied to either a negative number or a non-negative number, we must consider both possibilities. So let's go ahead and investigate. So we have 2x minus 4. The expression inside the absolute value bars can either equal a positive 8, or the other possibility is the expression inside the absolute value bars, 2x minus 4, can equal a negative 8. Regardless if it equals an 8 or a negative 8, if we put absolute value bars on it, we're going to get a positive 8 every time. Okay, so let's go ahead and find the solutions here. So we can we can add 4 to both sides. We're just solving for x here. We have 2x equals 8 plus 4 is 12. We can divide both sides by 2 to isolate our variable, so we have x equals 6. So that's our first possible value for our solution to the absolute value equation. All right, let's go ahead and solve the other one. So we can add 4 to both sides. And sorry about that, we're adding 4, not 9. These two terms cancel. So we have 2x is equal to minus 8 plus 4 is a minus 4. Let's go ahead and divide both sides by 2. That'll give us x is equal to minus 4 divided by 2 is just a minus 2. And minus 2 is our second possible solution to our equation. Now we need to check these by plugging each one in separately into our equation. And if it remains true, then our solution is valid. So we have the absolute value of 2 times x, which is 6, minus 4, equals 8. 2 times 6 is 12, minus 4 equals 8. 12 minus 4 is 8. The absolute value of 8 is indeed 8, so that checks out. All right, let's look at minus 2. So we have the absolute value of 2 times a minus 2, minus 4, excuse me, I'm running out of room here. The absolute value of 2 times a minus 2 minus 4 equals 8. 2 times minus 2 is a minus 4, and we have our other minus 4. Should equal 8. We can add a negative here. So we have the absolute value of minus 4 plus minus 4 is minus 8 equals 8. And this is indeed a valid solution because the absolute value bars will turn minus 8 into a positive 8. So both solutions are indeed valid for our given equation. All right, let's make some room here. Not a whole lot to these. So let's do a couple more for practice. We have the absolute value of 3x plus 1 equals 5. All right, so let's go ahead and write our two equations and solve them separately. So we have the first possibility is 3x plus 1 equals 5. And the second possibility is 3x plus 1 equals a negative 5. Regardless of either case, we can put the absolute value bars like we do over here, and that will turn it into a positive 5. Whether we have positive 5 or negative 5, we would get a positive 5. So this makes sense. Let's go ahead and solve them. So we're subtracting 1 from both sides, solving for x. So we have 3x equals 5 minus 1 is 4. Let's go ahead and divide both sides by 3. Those two terms cancel, so we have x is equal to 4 over 3. That's our first possible solution. Let's find the second one. So let's subtract both sides by 1. Those two terms cancel, so we have 3x equals minus 5 and minus 1 is minus 6. We isolate our variable by dividing both sides by 3. So we have x is equal to minus 6 divided by 3 is a minus 2. That's our second possible solution. Now we check these two solutions by plugging them in one at a time for x into our original equation. So let's take a look. We have the absolute value of 3 times x, which is 4 over 3, plus 1 equals 5. All right, so these two terms cancel, so we have 4 plus 1 equal 5. The absolute value of 5 equals 5 is a true statement, so x equals 4 over 3 is a valid solution for our equation. Now let's see if minus 2 is. So we have the absolute value of 3 times a minus 2 plus 1 equal to 5. Let's go ahead and solve this. We have 3 times minus 2 is minus 6 plus 1 equals 5. Absolute value minus 6 plus 1 is minus 5. Still have our equals 5. And the absolute value of minus 5 equals 5 is a true statement, which means x equals minus 2 is a valid solution for our given equation. Very straightforward. Let's do a couple more for practice. We have the absolute value of x over 4 minus 1 is equal to 1/3. Now we have two different possibilities that we need to investigate. We have either x over 4 minus 1 is equal to a positive 1/3, and our other possibility is x over 4 minus 1 equals a negative 1/3. All right, we need to solve both of these. So we can add 1 to both sides, plus 1. These two terms cancel, giving us x over 4 is equal to 3 over 3, and 1 over 3 is 4 over 3. Simply converted 1 to 3 over 3 so we can add it to this fraction. Let's go ahead and multiply both sides of this equation by 4 so we can isolate our variable x, cancel the denominator, so we have x is equal to 16 over 3. 4 times 4 is 16 over 3. So that's our first possible solution. Let's go ahead and look at the second one. Let's add 1 to both sides, so we have x over 4 is equal to 3 over 3 minus 1 over 3 is 2 over 3. Let's multiply both sides by the reciprocal. Those two cancel, just like over here. We have x is equal to 8 over 3. 4 times 2 is 8 over 3, so we have 8 over 3 is our second possible solution. Let's go ahead and check these two solutions. Let's plug in 16 over 3 first. So we have x is 16 over 3. Let's put it in parentheses so we're clarifying that we're substituting in. We have 4 on the bottom. Let's go ahead and make that 4 over 1 so we can make the next step a little more simple. Everything stays the same, so we have the absolute value of 16 over 3. When dividing by a rational number, we don't ask why, but we flip the second and multiply. So we have 16 over 3. Oh, excuse me, we need to flip the second one. 16 over 3 times 1 over 4. 1 over 4 is the reciprocal of 4 over 1. Put those in parentheses just to clarify what our next step is. Minus 1, and we have 1/3 on the other side. Let's go ahead and factor out a 4 out of both of these terms. So we have the absolute value of 4 times 1 is 4. 3 times 1 is 3. Minus 1. 1's the same as 3 over 3, so let's go ahead and convert that. So our next step, we can go ahead and subtract the two fractions. So we have the absolute value of 4/3 minus 3/3 is 1/3. The absolute value of 1/3 equals 1/3, and that's indeed a true statement. So 16 over 3 is indeed a valid solution. And let's clear us a little room here. And let's check our other solution, 8 over 3. So we have, we have our original equation right here. We're plugging in 8 over 3 as a possible solution, plugging it in for x. So we have the absolute value of 8/3. Let's put it in parentheses, divided by 4. And once again, we're going to write 4 as 4 over 1 minus 1 equals 1/3. Let's go ahead and flip our fraction. So we have 8 over 3 times 4 over 1. The reciprocal is 1 over 4. Let's put that in parentheses. So minus 1 equals 1/3. We're just using what we know already to solve this. Let's factor out a 4 out of both of these terms. So we have the absolute value, 2 times 1 is 2, over 3 times 1 is 3, minus 1, once again we'll convert 1 into 3 over 3, equals 1/3. The absolute value of 2/3 minus 1/3 is a minus 1/3, equals 1/3, and this is indeed a valid statement. The absolute value of minus 1/3 equals a positive 1/3. Anytime we're taking the absolute value of either a positive or a negative number, we will get a positive number every time. All right, let's clear a little room and do one more. Let's take a look at the next one. We have x, the absolute value of x minus 4 equals 0. This is pretty simple. We just wanted to get some more practice in. We have two separate possibilities. We have the expression inside the absolute value can equal a positive 7, or the expression inside the absolute value bars can equal a negative 7. Either way, if we put on the absolute value bars, we'll get this positive 7 every time. So let's go ahead and solve for x here by adding 4 to both sides. We have x equals 11, which is our first possible solution. Let's find our second one. Let's add 4 to both sides over here. Those two cancel, so we have x is equal to minus 7 plus 4 is minus 3. And that's our second possible solution. And we'll prove that they both indeed check out by plugging them into x in our original equation. So we have the absolute value of 11, plugging in 11 for x, equals 7. The absolute value of 11 minus 4 is 7. We have our equals 7, and that's a true statement. The absolute value of 7 is 7. Now let's check x equals minus 3. We have the absolute value of x, which is minus 3, minus 4, equals 7. Let's add a negative instead of subtracting. We have the absolute value of minus 3 and a minus 4 is a minus 7, equals positive 7, and this is indeed a true statement as well. The absolute value of negative 7 is a positive 7. Okay, so we're solving absolute value equations. We already know how to do this. We have all the tools, we have the knowledge to do it. Now I'm just introducing the concept that when we have an absolute value equation, we need to investigate two different possibilities. The expression inside the absolute value bars can either be positive or it can be negative, and we'll get the same positive answer. So I'm out of time. We'll look at some more of these in the next section. I'll see you soon.